All right, we're looking at what's called logarithmic differentiation. And there are really two things that we can do with this. One of them is making hard derivatives easier. So let's look at this. Suppose we were told to find the derivative of this function. Now that's going to be a pain because we'd have to do this, first thing we do is use the quotient rule. And so we do low d high. Well, when we do d high, the derivative of the top, we've got to use the product rule and the chain rule. So low d high minus high d low, when we do the derivative of the bottom, again, we've got to use the product rule. So this thing would get pretty complicated pretty quickly. So it would be a lot easier if there were a natural log here so that we could split it up. So that's the idea. We're going to take the natural log of both sides and get this equation here. That's the thing that makes this logarithmic differentiation, is that before we do the logarithm, before we do the derivative, we take the log of both sides. So we do this, and now we're going to use implicit differentiation. Because what we've got now is, on this side, we don't just have this thing solved out for y. We have ln y. So what we're going to do over here is take the derivative of this side and the derivative of that side. When we do the derivative of this, we're going to get, well, derivative of natural log of y. We're going to have to put y on the bottom and its derivative on top. But before we do the derivative, let's expand this side out using the log rules. All right, so what we've got here is natural log of y equals, and I'm going to go ahead and do all of this at once. The x squared is going to give me 2 ln x. This is going to give me plus 9 ln 1 minus x. X to the fourth is going to give me minus 4 ln x. And cosine is going to give me minus ln cosine x. Now, sometimes people get a little tripped up on this because they see the cosine down here and it looks like it's multiplied by the 4, by the x to the 4. And they want to make that a plus instead of a minus. But just keep in mind, each one of the terms on top gives you a positive log, and each term on bottom gives you a negative log. The reason is you could rewrite this if you wanted to as ln of the top minus ln of the bottom, and then this negative would distribute across. When you split this into several logs, the negative would distribute across there, and that's how you'd wind up with those. All right, so we've got this. Now the derivative of this derivative of natural log of y goes on bottom, its derivative goes on top. And then the rest of these we've done. 2 over x plus, this is going to be 9 over 1 minus x times its derivative on top. 4 ln x is going to be 4 over x. Then ln of cosine is going to be cosine on bottom. Derivative of cosine is negative sine. So y prime over y is, let's see, before we do this, notice 2 over x minus 4 over x, those are both like terms, so we can combine those. 2 minus 4 is negative 2. And then this becomes minus 9 over 1 minus x. And then this last term here becomes plus sine over cosine is tan. Notice we combine these two to get this. We could have, if we started out, we could have canceled the x squared and the x to the fourth and just been left with an x squared on the bottom. And if we had canceled that before we expanded, it would lead us to the same thing here. Okay, we're almost done. The only thing is we don't have the exact answer because we're supposed to find y prime. What we've got here is y prime divided by y. So what I need to do is multiply both sides by y. So what I get here is y prime equals minus 2 over x minus 9 over 1 minus x plus tan x. And instead of putting y here, let's put what y is equal to. Scroll back up here. Y was our original function, x squared 1 minus 9 to the 9th over x to the 4th cosine x. Now you could distribute that through and stuff would cancel on each one of these, but I'm not going to ask you to do that. This is sort of big and ugly. So I would say leave it like it is, and that's our answer. All right, let's do a few examples. You know, maybe it's worth writing the directions out here. So for logarithmic differentiation, I'm going to write the steps over here. First, take ln of both sides. Two, expand the logs. Call them logs. So expand the ln's on the complicated side. After you do that, you take the derivative implicitly. And really, the implicit part, the only thing that makes it implicit is over there on the y, on the ln y, that has to be y prime over ln y. I'm sorry, y prime over y. That's the only bit that makes it implicit. And then at the end, multiply both sides by y. If you look at it, that's what we did here. We took the natural log of both sides, we expanded the log, we did the implicit derivative. The implicit derivative is what gives us this thing. And then we just have to multiply both sides by y to get the answer completely in terms of x. So let's do a few examples. Let's see, how many examples do I have? I've got 511, 512. Yeah, let's do both of those. And then we'll save the rest of it for the final video for this section. Use logarithmic differentiation to find the derivative of this thing. Now this thing wouldn't be impossible to do by normal differentiation, but logarithmic differentiation will make it easier. So let's see, we get ln y equals ln of 1 plus x squared to the 4th times x squared minus 4 to the 7th. So let's break this into two logs. We'll get one log for this, one log for that. So this is 4 natural log 1 plus x squared, then plus 7 natural log x squared minus 4. Now we'll take the derivative of both sides. Derivative of natural log of y goes downstairs, its derivative goes on top. This, we've got a 4. That goes on bottom, its derivative goes on top, its derivative is going to be 1 plus 2x. Let's see, x squared minus 4 on bottom, its derivative 2x on top. And now I need to multiply both sides by y. So I get y prime is 4 times 1 plus 2x over 1 plus x squared. Now let's see, this will become 14x over x squared plus minus 4 times the original y. The original y was 1 plus x squared to the 4th times x squared minus 4 to the 7th. So our answer is kind of big and ugly, but it gets the job done. All right, last example for this video. Differentiate this function. All right, I'm going to be lazy on this problem. I am going to cram the natural log in here. Natural log of this equals natural log of that, instead of rewriting it. So what I get here is natural log of y is equal to, now I'm going to split this up. The square root of x gives me 1/2 ln x. And I get plus ln of x cubed plus 9 minus 3 ln of 2x plus 4. And if I gave you this problem on a test and asked you to work it out, it's perfectly fine with me if you cram the ln in up there instead of rewriting the thing again. Okay, so y prime over y is going to be 1 over 2x plus, let's see, this one is x cubed plus 9 under 3x squared. Let's see, this is going to be 3 on top, 2x plus 4 on the bottom, multiply by 2 on top. Then we'll multiply both sides by y. And I'm going to be lazy again here. I'm going to do two things. I'm just going to copy, instead of putting y here, let's go ahead and copy what y is. So let's see, these cancel, and y prime is equal to this. It's kind of amazing to be able to do that derivative of that really complicated function in 2 lines. But that's the power of logarithmic differentiation. I mean, the advantage is it gives it to us in 2 lines. The disadvantage is, you know, if we wanted to set this equal to 0 and solve, I guess we could set this bit equal to 0, but setting this part over here equal to 0 is going to be a little more complicated. So anyway, that's the last example on this part of this section. So we will we'll pick up in the next video. This is Veronica, no, this is Pipsqueak. We have 2 black cats. This is the squeak. All right, we'll pick up in the next video.